Hello and welcome to CSE Core Concepts in the series of computer networks. In this video, I am going to discuss about the TCP IP reference model. In my earlier video, I have discussed about the OSI reference model, which is used as a standardization. Now, a TCP reference model is named after the two primary protocols, that is TCP, which stands for Transmission Control Protocol, and IP, that is the Internet Protocol. Now, a brief history about this is that the ARPANET was a research network which was sponsored by the US Department of Defense. So it was only for the Department of Defense, so it was a closed network. Then, when it became successful, they eventually connected some hundreds of universities and only government installations, and the connection was done using some leased telephone lines. Now, eventually, when the satellite and the radio networks were added later, and the existing protocols had some issues for internet working with them, so they referred to a new reference architecture. So this TCP IP reference model came into existence. Now in this TCP as differed from your OSI model where you had 7 layers, the TCP has only the few layers because the application layer is encompassing some of the layers. So TCP IP provides user with the physical standard, the transportation functions, the network interface, and the internetworking functions that correspond with the first 3 layers of the OSI model. So here in this figure, you can see a brief comparison between the OSI and the TCP IP model. So the presentation and the session layer is not present because it is clubbed in the application layer. Then the transport layer is there. For the network layer is referred as the internet layer and the data link layer as the link layer. So let us get started and understand each of these layers in brief. So we get started with the application layer. So it is used to maintain a smooth connection between the application and the data and the user for the exchange of data. And hence they offer us various services of the application layer, such as remote handling of any system, and for providing email services, etc. So they contain all the higher level protocols such as your HTTP. Then you have the virtual terminal. If you want to connect to a remote computer, you can use the telnet. Or if you want to perform some file transfer, you can use the FTP protocol. And of course, for mail, you can use the SMTP protocol. Then comes your transport layer, which is responsible for establishing the connection between the sender and the receiver's device. And it also helps us for dividing the data which has come from the application layer. It will divide the data into small packets. Okay, and these packets are then sent to the receiver end. And there it is also performing the task of maintaining the data, that it ensures that the data is transmitted without any error. And of course, the flow control rate, that the speed of the sender should not be more than the receiver, and for smooth transmission of data. Now there are two types of transport protocols which have been defined. That is, the first one is the TCP protocol, that is Transmission Control Protocol, which is a reliable connection oriented protocol, and it allows the byte stream from one machine to be delivered without any error on the other machine. It segments the byte stream into small messages and passes on to the internet layer. This is the work of TCP. At the destination side, on the receiver's end, the TCP will receive these small bits of data, and it is going to reassemble as the received message in the output stream. Moreover, the work of TCP is also to handle the flow control, so that it ensures that the sender is not very fast and it is not dumping up all the messages on a slow receiver at a very higher speed than it can handle. Now, the another protocol in the transport layer is the user datagram protocol, which is an unreliable connectionless protocol for application who do not require the TCP sequencing or flow control, and they provide on their own. Now, it is majorly used in the applications for one shot, like if you are sending a message and you are not bothered whether the message is received properly or not, or you do not expect any type of acknowledgement. So it is used for client server type request reply queries and applications in which your prompt delivery is important, because here it does not perform the job of sequencing and all. So obviously the data transfer is faster rather than the accurate delivery. You are not bothered whether all the packets reached or something like that. Okay, so you just want it to be delivered anyhow, like such as a speech or a video file. So this is how your transport layer works. Then comes your network layer. That the work of the network layer is to control the transmission of data over the network modes and enacts protocols related to various steps. Okay, now it helps the host to inject the packets into the network and allow the packets to travel independently, of course by using some proper routes. Okay, and may even arrive. Now the problem is that the packets which you have sent, they each of them are taking different routes. Now it is very much likely that on the receiver side they may receive differently. Okay, so the packets may not come in a sequence as they were sent. So on the receiver side the work is to reassemble the packet if necessary. Now, here there is a proper packet format and protocol which is called as the Internet Protocol, and another companion protocol to Internet Protocol is called as the ICMP, that is called as Internet Control Message Protocol, which helps in issuing of proper message format. The job of the internet layer is to deliver these IP packets where they are supposed to go. So that is the work of your network layer. Then comes the link layer and the network layer. So some of the protocols which are used in the network layer are the IP protocol, which helps the device which provides each and every device with a unique address. Unless and until you have a unique address for the device, how would you route your packets to your destination? So the IP address is responsible for routing the data over the communication channel. It will tell you the source address and the destination address. And another major protocol is the ARP, which is called as the Address Resolution Protocol. This helps in finding the actual physical address from the IP address. The IP address which is assigned, it is a virtual logical address, but every device has a physical address associated with it. So in the address resolution protocol, they maintain that which IP address belongs to which physical devices. Okay, so this mapping of this is done by the address resolution protocol. Now you have got the network access. Sorry, so we have seen the application layer, the transport layer, and the internet layer. Now let us have a look at the link layer. So this is a network access layer. Okay, so the combination of data link and the physical layer, where it is responsible for maintaining the task of sending and receiving data in raw bits. That is in the form of a binary over the physical medium. Now in the OSI model, you had the you can say you had the physical layer separately. But in this TCP IP model, it is clubbed with this layer, and hence the data which is in the form of packets, it is broken down into raw bits of binary numbers in zeros and ones, and it is then passed through the communication channel. So it uses the physical address of the system, because when it is physically going, it has to reach the physical address of it requires the physical address of the destination. So these are some of the popular protocols in the TCP IPs. At the application layer, HTTP, SMTP, RTP, and DNS. Then in the transport transport layer, you have the TCP protocol and the UDP, where TCP is a connection oriented reliable protocol and UDP is a unreliable connectionless protocol. In the internet layer, you have the two popular protocols, that is the internet protocol and the ICMP for generating messages. And at the link layer, you have the DSL, SONET, 802.11, Ethernet. Ethernet is used for the LAN communication. So, for establishing the link or the networking and passing the data through the physical bits is done in this link layer. So I hope you understood. This was a very brief discussion about the TCP IP reference model. Please don't forget to like, share and subscribe to CSC Core Concepts. Thank you.